Hello and welcome to our very first online workshop. I'm James Robinson. I'm the lead PyAcademy trainer in the UK, and I'm here today to talk you through getting started with the Sense Hat. So I'd like to first of all welcome all of those people that are watching live, and also all of those people that are going to be watching this after the event and watching on YouTube on demand. So this workshop that we're going to work through today is based upon a session that we run at PyAcademy. And through this session, we're going to learn a few things, hopefully. So let's just have a quick look at a session outline and talk about what it is we're going to learn. So we're going to play around with this device called the Sense Hat, which we can use to represent images using some data. We can control the Sense Hat's LED matrix, and we're going to work on doing that. And we can also read and react to sensor data. So over the course of this session, we're going to work through those three objectives. And there's a few things that you're going to need. And for that, let me just go through those things that we're going to need for this session. So these things should have been in the welcome pack that you would have received if you registered for this event. The first is an image planning sheet, which is a paper sheet with some grids on and some colourful little icons. So we're going to use that as part of a planning activity later in the session. You're going to need some pencil crayons or some similar colouring implement. You're also going to need access to the Sense Hat Trinket emulator. We are not going to be using real Sense Hats for most of this session, and so you will need access to that emulator. And you can get to that emulator by following the short link there on your screen, which is rpf.io/GSSH1. And finally, alongside the YouTube interactive conversation that's going on probably right now, we can also use a tool called Menti. We're going to use this at 3 points during the session to gauge our audience response, to get a bit of feedback from you guys, and get your thoughts on a couple of questions. To use Menti, we go to www.menti.com, and for this session, you need the code 199665. I'm going to do that straight away. So I think a few people have already found this. But what we're going to do is we're going to spend a few moments just introducing the people that we have on the call with us today. So if you go to menti.com, you should find a question there where you're able to tell us who you are, in what context you teach, and just briefly a little bit about your experience with Python, the Sense Hat, teaching computing, and so on. So we're going to spend a few minutes doing that. And whilst you're away doing that, I would like to spend a few moments introducing two people that we're very fortunate to have with us today. We're going to go to Heidi first in a second, but we've got Heidi, who's joining us from the US, and we've got John, who's joining us from York kind of area in the UK. So Heidi, would you like to spend a few moments just introducing yourself to the people that are watching? Thank you.
Sure. Hi, everyone. Good to see you out there. It's early here on the West Coast in the US. My name is Heidi Baines. I'm a Raspberry Pi certified educator. I'm a teacher on special assignment for my school district where my focus is instructional tech. I'm lucky enough to get to teach a Raspberry Pi course at our alternative school for 6th through 12th graders. And I'm really excited to be here. It's a holiday for us here, so it's able to hang out and talk Raspberry Pi.
Thank you very much, Heidi. That's great. Good to hear from you. And it's also great. I'm really appreciating the fact that it's quite early over there in the States. So thank you very much for joining us all the way from over there. And if we can also, let's just switch over to John. And John's going to say a few words about.
I'm John. I teach computer science in a secondary school in the UK, a girls' independent boarding school. I'm Raspberry Pi certified educator as well. I also run a Raspberry Jam in my hometown of Hull. So yeah, use the Sense Hats a lot in our teaching, use Python extensively as our main programming language, but really excited and interested to see what everyone comes up with today in this session.
Okay, that's great. And you guys have been introducing yourself on the Menti board as well. So we've got John, who teaches computer science at a secondary school in the UK. Great to have you with us, John. We've got Scott, who I think was one of the first people to introduce himself way before the session started, who teaches science and physical computing. We've got Liz, who's joining us from Manchester. We've got a couple of colleagues of mine as well. We've got Angeli from the Museum of Computing here in Cambridge. So it's great to have so many of you here on the call with us. Thank you so much. And we're going to come back to Menti a little bit later in the session to ask some specific questions about your thoughts around some of the activities we're going to do. So let's get started with our activity. So what we're going to do is we're going to be using this today in our session. Okay, so this is the an AstroPi unit. So inside this AstroPi unit, we have a tiny little board called the SenseHat mounted on top of a Raspberry Pi. And we have two of these running at the moment on the International Space Station. And those are being used by astronauts, running code written by students across the UK and also European students. And so most of what you see here, this beautiful case that we have here with all the etchings that sort of Dave is really proud of, that way around, there we are. Most of this case is a high-grade aluminium case, which kind of allows the Raspberry Pi to perform in the environment on the International Space Station. What's really nice about this is that your students can interact with this hardware that the astronauts are using on the space station in their classroom, okay? So they can use the same technology in the classroom in their lessons. And let's go and have a look at the slides, and we'll have a look at that hardware now. So the SenseHat was designed specifically for the AstroPi project, but you can use it in all sorts of contexts. The reason we particularly love the board, and it's really popular amongst educators, is first of all, we have this 8x8 grid here. So we have this grid of LEDs. And these LEDs, each of them, we can light with a certain amount of red, green, and blue to produce a color. And we'll talk a bit more about RGB mixing later on. We also have on the board a whole suite of sensors. So this chip here can sense temperature and humidity. This chip here can sense the barometric pressure. We have a chip over here which can sense the accelerometer values from the board, so it can sense the orientation of the SenseHat. And finally, we have a mini joystick there, which we can use to control various things. So we're going to have a play around with this, but obviously you guys don't have SenseHats in front of you. So one of the great things that we have is this emulator. So we actually have two emulators. So we have a web-based emulator, which is the one pictured on the left-hand side, and that's the one we're going to be using today. And we also have a local emulator. So if you have a Raspberry Pi, this comes pre-installed, and you can use both of these to engage in SenseHat projects without the physical SenseHat. And which one you use really depends on your context, what you're trying to do. But the great thing about this is that you can give it to your students, and they can test their ideas on the virtual SenseHat before then taking it onto the real SenseHat. So you might only have one SenseHat per class or none, and kids can engage in this kind of activity. So I think it's about time we got you guys involved in this activity. So I would like you all, if you haven't already, to go and visit the link at the bottom of the screen now, rpf.io/GSSH1. And that should take you to an empty trinket window, which may or may not have the SenseHat on the right-hand side, but you should have an empty code window. Cool. And then what we're going to do is I'm just going to show you really quickly how we can get our first program working with the SenseHat. So on the next slide, we've got a short video clip which we're going to use to just talk through what we're going to do. So in the code window on the left-hand side, we first of all need to tell our Python program that we're going to be using the SenseHat. And so we add this line, from SenseHat, import SenseHat. Note the capitalization on the second mention of SenseHat. This pulls the ability into our program to use the SenseHat and allows us to then talk to it. The next line we're going to write is we're going to create a variable, which is effectively just a name, that we're going to use to talk about the SenseHat that we are talking to. So we've said sense equals SenseHat. And all that does is it creates an object or a connection to the SenseHat that we can then use to drive the SenseHat to do things. We could call sense anything. We could call it S or Bob or Jim, but sense seems relatively sensible. And then finally, the final line of this program we're going to run is we're going to ask it to show a message. So we're going to say sense.showMessage, and then inside some brackets or parentheses, and then in some speech marks, we're going to write a string message. And that string message can be anything you like. And once you're happy, you're going to click the play button, and that message will display across your screen. Now, you may not have done that while I was talking through it, but what I'm going to do is I'm going to leave that code on the screen, but we're also going to switch over and see Heidi and John work through that activity now. So we're going to spend 2 or 3 minutes. If you haven't already, have a go at that activity along with the session, and we're going to go and see. Let's go to John first of all. So if we cut over to John, John is actually working, I think, with the real sensor. Is that right, John?
I am, yeah. So I typed it in actually whilst you were showing, James. So I've just pasted that back in, and hopefully you can see in the bottom corner my actual real sense hat down here. And if this works, we should get the message displaying. Hang on. A bit blurred.
That's great, and you've gone for the baking sheet trick there to try and
try to diffuse it a little bit. It seems a bit blurred.
Kind of worked.
We'll try again.
Cool. That's great, John. So we can see your message scrolling there, and I think what that shows is that there's a real physicality to this kind of activity. I think the Sense Hat does bring something to it. We can see the message scrolling there. There's an immediate reaction from the code that the students have written. That's great, John. We'll come back to you in a moment on the next activity, but let's switch over to Heidi. Heidi, could you share your screen with us? Is that possible? Okay, so we're having a couple of technical issues seeing that, Heidi. But if we get your screen back, then we'll come to you in just a second. But I think we've managed to get 2 demonstrations of that working. Okay, and we'll have a look at perhaps Heidi's on the next example while we kind of figure out the screen sharing thing. So that's great, and hopefully those of you that are watching the session live have been able to write a piece of code that makes a message appear, which is a great starting point for interacting with the Sense Hat. But now what we want to do is we want to just go a step further, and we're going to try and look at how we can represent some data using the Sense Hat. So, or use data, sorry, to represent information. So we're going to go to our next slide, and here I want to talk really briefly about how computers represent information. So all information inside a computer, whether it's music or video or images or sort of 3D objects within a game, all information essentially boils down to numbers. And we're going to look at a really simple example here of how a computer uses 3 values, the red, green, and blue, to mix them together to create a unique color value. And with this, we can create a whole spectrum of different colors. So what's going on here is with the sliders, which may or may not be clear on the viewing end of this, as we slide the sliders up, we're changing the amount of red, the amount of green, and the amount of blue in the overall color. The red, green, and blue vary between 0 and 255. And as we change those values around, we get a different resultant color. And with just those 3 values, we can represent something like 65 million different colors, which is phenomenal. And at the bottom there, we've also got, for anyone teaching sort of older students or doing stuff around web design, we've also got that color represented rather than 3 decimal numbers. We've got it represented as a hexadecimal string. So a hexadecimal string is just a shorthand way of representing those numbers. And that's often used in web design and lots of other design work. Okay, so that's how the color mixing works. So now's the time to do a little bit of coloring in yourself. You should have in front of you, hopefully, a planning sheet, which looks like this. And what we're going to do is we are going to spend a moment just doing a bit of colouring in. At the end of a long day, we're going to spend a bit of time relaxing and doing a bit of doodling. On the right-hand side, we've got a palette of colours. And each of the colours in there, we've broken down into the constituent parts, the red, the green, and the blue. And so we've got the rainbow spectrum there, and we've also got black or blank and white. And what we've done with each colour is we've given it a specific letter to represent that colour. You might notice that things like blue have an odd letter. We're using U rather than B. And that's because as soon as you get more than one colour with the same initial letter, you need to start getting creative. So we've used B for black or blank. And so we've had to use a different letter to represent blue. So we've gone with U. What I'd like to do is I'd like to spend a few moments, just first of all, I would like you to make yourself a little picture, okay? It doesn't have to be as artistic as mine is, but it should use two colours. It should really use two colours, but don't go mad. You don't want 64 different colours in there because you're going to create lots of work for yourself later on. Your image could be abstract, it could be representative of something, but have a go now at just doodling a picture. Once you've done that, you're then going to label each of those boxes with the corresponding letter from the right-hand grid. And if you've got all of that done, then you can then have a go at just adding a second picture in. The pictures don't have to be connected, but they should be different. And the other thing that I've done is image one, I've given a name. I've called it rain, and image two, I might call sun. So that's great. And the other thing I just want to say at this point as well is if at any point during this session you feel like you want to share what it is you're doing, take a picture of your doodles, then tweet them out to the Pi Academy hashtag where other people can see them. So now we're going to go, let's go back to Heidi first this time. And Heidi, have you been doing some colouring in over there?
I have. My son is not nearly as artistic. I've got a sun going here, and I'm going to do a second sun here in a different color, but I've got it labeled with blue and yellow. And then I've named this sun 1 because this is going to be sun 2.
That's great, Heidi. Thank you very much. And I think we're still getting a couple of little connection issues there. But for those that didn't catch what Heidi was saying, I think she's drawn. I mean, she's claiming it's not artistic, but I think it looks awesome. We've got that lovely sun with a blue background there, and she's coloured in that and labelled each with a letter. And she was saying she's going to draw a second sun in the box later on. I think video is working reasonably well, Heidi, but maybe later on if we'll just hold the pictures up nice and clearly, and we'll try the mic again then. John, how are you getting on with your artistic work?
Yeah, colouring away. Here we can see it's going to be a moon, hopefully. Might leave a couple of white ones in there for little stars around it. So yeah, colouring that in. Not sure what I'll do for the second one yet, though.
Great. That's great. So has anyone got any thoughts about the kind of the practicality of this activity? Why would you use this kind of activity with your students? So John, perhaps whilst you're doing your doodling, could you kind of buck the stereotype and do some multitasking for us as a man, and tell us a bit about like what's the value maybe in this kind of activity?
I think there's huge value as soon as you kind of take the students away from their computer and you ask them to just kind of do something tactile, hands-on, akin to the unplugged things and stuff like this, and just get them thinking about the process. Often when I'm starting to get kids writing a program, I'll just hand out sheets of A3 paper and big marker pens and say, right, just start writing. We're not thinking about code. We want to think about the program. So I think it helps them contextualize and break down what they're doing rather than staring at a blank IDE or whatever and thinking, I don't know what code to write, I don't even know how to start. I think it gives them that way of approaching the problem.
That's great, John, thank you. What we'll do is that I'll let you get back to your colouring in and sort of complete your artistic work there. I think the value of this kind of thing, as John said, is about sort of separating out the thought process and the actual sort of act of programming this solution. It gets us to think about how the data is represented, to do a bit of planning. And I think the idea that John mentioned of just getting kids writing the ideas. And I think sometimes the medium of trying to like think about code can often be a bit of a blocker for students because they jump straight to that. Whereas if they have the chance to externalize their ideas, their thought processes around what they want to make before they get to the computer, then it kind of gives them a chance to uncover some of the kind of the problems that they might have as they go on that journey. Cool. We're going to try switching back to Heidi one more time and see if she's got a second image. And we're going to try and do her microphone again.
Okay.
Heidi, you're still muted.
Let's try again. Better?
Yes, we can hear you now.
I'm having, hopefully you can hear me, but I'm working on this second sun. And the plan is for the sun to get progressively darker. It's warmer. So I have an identical sun because it'll, a bit of an animation, I hope. And hopefully you can hear more than every 5 or 6 word that I'm saying, but it now. You can hear me.
We heard most of that, Heidi. That was great, and I think the idea of like we've just done 2 frames, but you kind of suggested with that you could have a progression, a series of frames that you could then you could turn potentially into an animation. So that's great. So hopefully we've given everyone at home time to do a little bit of planning of their image. So now let's think about the programming of that. So again, we're gonna cut to a short video clip, but before we do that, we've pre-populated some of the code for you in this second link. So if you go to rpf.io/GSSH2, then you should find some of the code has been pre-populated for you in that view. And we're going to talk through really briefly how to go about representing this image in code. So let's have a look at that. So here we can see the program that I had before, but what I'm going to do is I'm just going to pause that for a second. We've got some similar elements to the previous program. We have our import line at the top. We've added a second import, which we're going to use later. We've imported time. We've still got our sense equals sensat so that we can talk to our sensat. And then we've done a couple of things here. First of all, I've defined each of the colors that I want to use in my image. So white is 255, 255, 255. Blank or black is 000. And at the moment, I'm in the middle of defining blue or U. So the first thing to do is to go and define the colors that you're going to use in your image. So I think for my rain, I also added another optional color. So I made one up. So this is A for gray. And that's 217, 217, 217. So you get all your colors defined. And then the next step, which I'm doing now, is I am naming the picture that I'm going to create. And I'm using the name that I had at the beginning. And then I'm going to use this structure, which is called in Python, it's called a list. And a list structure is just a series of values separated by commas, sorry. And what I'm doing now is I'm just putting all of those values in. And because I've got 64 pixels on my sense hat, I need 64 values. I could write them out as a really long list, but to make it represent a bit more what it should look like in the final on the sense hat, I'm spacing that out and spreading it over several lines. So I've put a B for blank, an A where I want there to be some grey, and I'm going to add in a second, after this line, I think, I'm going to add in some white for the little raindrop, or blue, in fact, blue for rain. There we are. So I'm going through and I'm adding a line for each line of the sense hat. So I should have an 8x8 grid. If you're typing this out, the spacing doesn't matter at all between those elements in the grid. Now I'm finishing my 8th line. And all I've done at that point is I've created a blueprint, a design of that image. And what I now need to do is actually make the sense hat display that image. And that's where the next command comes in, which is where I'm going to tell my sense hat to set pixels. And inside that, I'm going to give the name of the pixel array that I've created. And then when I play that, I'm going to get my pixel array appearing on the screen. There we go. So relatively straightforward. I'm going to give you a few moments to work on that, say 2 or 3 minutes to have a go at that. I'm going to leave the code up on my screen here. And what we might just do is let's just leave that on the screen for now, and we'll go and we'll have an audio conversation first of all with, let's go to John first of all on this one. And John, the question I want to ask you, as you're typing code, is whereabouts in this example do you think students might get stuck with this activity?
The ones I see, they missing commas off of the end of the lines. The one they'll often get is adding a comma after the very last one that goes in the list. Capitalization is one that often catches my students as well. So getting the capital S, capital H. The one that it's not going to get them in this, but one we do see catch people out with sense hat is that we use the English spelling of color, and they get so used to using the American spelling of color in all other types of Python that when they come to sense hat and it's spelled the English way, we'll often see them getting it the wrong way around.
Yeah, that's great. I think that's a really good point. I think the brackets and the commas are really sort of key points. And I think, as you say, the capitalization can be a real issue. Something which I realized I didn't sort of mention was some people that might not have written any Python before, and they might not know what the green text is here. If you're there and you're typing that out, you don't need to. This is simply just an annotation. And so you can just ignore the that text. It's just there for the programmer's notes. And then I'm going to ask the same question of Heidi and remind her to unmute her microphone before she starts talking. So what common sort of points do students failure with this task, Heidi?
Yeah, I missed some of that question, but response, it sounded like problems that students may have when they with Python and the sense hat was the question. And I would second everything that John said, the commas especially, and the capitalization of sense hat as well. And in addition, the parentheses trip them up. But I will say one thing they really enjoy is the mixing of the colors. I'll have planned for students, to run through making an image, but they really enjoy when they get into the RGB color codes, finding new colors and finding new ways to apply those colors to what they're doing. So that's something that I'm learning to leave more time to experiment with, because they seem to really enjoy that.
That's great, thank you. And I can see, because I can kind of see what's going on in different parts of the call, I can see John, I think, is doing some testing of his sense hat at the moment. So maybe we could cut over to John. Now, we can definitely see, John, there that you've got some lights lit up. I think I can just about make out the difference between some blue and some yellow there, which is kind of, I can kind of see the crescent moon there.
Just trying to tweak the camera setting.
What you might find worth doing, John, there is you might want to dim some of those values so they're not quite as bright. That might help us see the image you're trying to create. So a bit more contrast between those two. Maybe we could jump over to see Heidi's screen in a second. So if she wants to kind of get that set up and share her screen, if she's got anything ready to show, then we can have a look at that. And I think there's a number of things that both Heidi and John sort of drew out of this activity. I think that recognizing of where students are going to have common issues is really important, and sort of being ready to pick up on those issues before they encounter them is really helpful. So I think we can switch over to Heidi. There we go. Yeah, there we are. So we can see Heidi's amazingly paradoxical screen there. It went kind of weird again. We caught
I'm going to try to
the sun there, which was great. Thank you very much, Heidi. But I think we've got a bit of time now to play around with.
I'm going to try again. Let's see.
And thank you to those people that are watching live who are bearing with us while we have a few little technical things. This is our first online workshop that we've run. What we're going to do now is I think we'll have a short moment of reflection. We've heard a lot from John, and we've heard from me, and we've heard from Heidi about the kind of challenges and the learning that's going on here. And what I'd like to do is I'd like to go to our second Menti question of the session, which is around the kind of learning that's going on here. And so I'm just going to move Menti on so you can answer this question as well. And so if you go to Menti now, you should find that there's a chance for you to sort of reflect upon and describe what you think the learning is that's taking place in this activity. So perhaps if we could spend a moment doing that. Hopefully we have a live audience still out there and they've not all left us, but hopefully we'll have a few comments happening on Menti in just a second. And I think it's always really, really important whenever we're looking at an activity like this. I think there's two strands. It's really engaging and fun, but at the same time, like, what is the learning? And that's something that as educators, we always obviously have to bear in mind. And we've talked about a few of those points, and hopefully we're going to have a few comments coming in on Menti in just a second. Yeah, voting's open. And then what we're going to do in a second with the remainder of the session is we're going to have a look at trying to use some sensors with the SenseHat and try and read some sensor values and use those to trigger some outputs from the SenseHat. So we can see somebody's contributed that there's some learning going on around RGB colors. We've used lists. We've controlled the SenseHat. Physically coloring the blocks remind you of animated drawing, which is a really nice point. It's a great hook. I think that's a really, that shouldn't be overlooked as a motivation for doing this kind of activity. If you can hook and engage your learners, that's really important. There's some stuff around, in fact, two things that came in at the same time there, the idea of perseverance and having attention to detail, fixing errors, cause and effect with creativity. Yeah, there's lots of good ideas there. There's some stuff around data types in Python. In this one activity, we've looked at strings and lists and tuples. There's obviously sequencing, attention to detail, persistence, color creation. That's great. Lots of sort of similar ideas there. Learning about accuracy delivers results. Keep testing until it's right. Great. So there's a good number of ideas there that we've picked up on from this one activity. That's great. I'm going to leave that question open. So if anyone has any further thoughts, please add them to that question. But I'm conscious of time, so we're going to have a look at our third part of this session, the third activity. We're going to have a look at those sensors again. So we're going to go back to our presentation, and we're going to just revisit the fact that we talked about the sensor earlier on, and we had these sensors there. So we can sense temperature, humidity, pressure, gyroscopic motion, accelerometer, and we've also got a magnetometer on board. we're going to have a go at capturing some data from those sensor values and use that to drive something in our program. And again, I've got a short video clip, which I'm going to use to illustrate that. So what we've done in this video clip is we've taken the code a little bit further. First of all, we've added our second image. So if we just scroll down a little bit, you'll see that we've got a second image in there. We've got sun, which I've defined. Okay. We also have defined yellow as an extra color in there that we're going to need to use. And then what I'm going to do is I'm now going to create a structure in Python called a while loop. And a while loop, and specifically a while true loop here, is an infinite loop that will repeat whatever is inside it forever. And so anything that's indented is going to be part of that loop. And what I'm going to do is I'm going to go to my sense hat and I'm going to ask it to get for me some sensor data. I've got a whole load of options, but for this example, I'm going to try and sense the pressure. Because I've got a weather-based sort of imagery, I want to get the pressure. But I also, as well as getting it, need to store it somewhere. So like we did here with these lists of colors at the top, I'm going to store this in a variable, making sure that it doesn't clash with the ones I've used earlier. So I'm going to say that P equals whatever the pressure value is. And I'm then going to ask Python a question. So I'm going to say if P is greater than 1,000, then I'm going to have a conditional statement underneath. And underneath, I'm going to say sense.setPixels. And I'm going to say that I would like to set the sun picture because high pressure, generally speaking, indicates good weather fronts or sun. I'm then going to give it another condition, which is using the else keyword. So if it's higher than 1,000, do this. Otherwise, set the pixels to rain. And this loop will go round and round and round and round, constantly checking the pressure. And depending on what the pressure is, it will display an image on the screen. So I'm going to stop my current program running and run this program. And the great thing about the emulator is I don't have to physically change the pressure. I can slide my little slider around. If I go over 1,000, I get a sun. Below 1,000, I get rain. Okay, and I can see sun, rain, there we go. So what I'm going to do is I'm going to leave that last section of the code on the screen again. And we're going to see if we can get you guys working on that. And again, remember, if you're working on adding some of this into your existing code, please take a picture of what you're doing, talk about what you're doing, and share it using the PyAcademy hashtag, which would be fantastic. So we're going to try for a final time. We're going to go over and we're going to see if we can have a look at Heidi's screen, which I can now see on my screen. So as long as Heidi doesn't touch anything and we don't touch anything, well, hopefully we're going to be able to see her screen. Let's go to Heidi and see if we can see that now. Okay, so we're still seeing our screen. And we're not seeing Heidi's. Right, so there's something weird going on there. Not quite sure what's going on. So let's go over and see what John is getting up to. And then we'll hear from Heidi in a moment and she can describe what it is that she went and she did.
So,
John, I'm going to switch over to you with your microphone. Let's hear from you, John, because I think you've done something
I can hear.
Hi. Yeah, I've done something slightly different. I'm using the get temperature. Hopefully you can see the code that I've got here. So the same as James, set up two images. We've got a moon and a sun with the color variables there. But then rather than using get pressure, I'm using get temperature because it's tricky for me to actually change the pressure on my real sense hat. Now, hopefully, when I run this, we should get one image, and then depending how hot it is in my office, I might be able to change the temperature of the sense hat to get a different image showing. Let's see. Right, okay, so we're above 32 degrees Celsius in my office, so we've got the sun showing. So let's see how hot I need to push it. Yeah, okay. It's quite warm in my office. So I might struggle to actually get the other one showing, unfortunately. Oh, there we go. Okay, so thankfully it's under 40 degrees C. And then hopefully I can, if I just flick to the Pi, I can kind of heat up the chip and try and make it change. That's the plan anyway. It did almost go. Might just adjust the level to say 38 and see if I can get that to work. There we go. So that's changing based on temperature there.
That's great, John. Thank you very much. And it's really great, I think, to see that physicality again when you interact with the sensor. Another way of raising the temperature, sometimes if you just sort of breathe on it, you sort of kind of breathe on the sensor, raise the temperature, and that's a really powerful demonstration of what's going on. And then I think we're still having issues seeing what you've done, Heidi, but perhaps if you would like to describe what it is that you went away and did while I've been talking, and then that'll be great to hear from you. Remember to unmute your microphone.
Oh, yes, I'm gonna stop sharing so that whatever that is on the screen stops. But so I did something similar with the temperature sensor as well. And as the temperature rises, the sun gets progressively darker. So here where I live, there's really not much rain, and it doesn't really get cold. And so I just had a progressive, sunnier, hotter sensor working, and I wish I could show it. I don't know why it won't show, but I have 3 different suns of a progressively darker color, and as it senses hotter weather, the sun gets darker and darker, so that if I were to look at that and see a deep red sun, I would know that it's outside.
Thank you, Heidi. And I think what we'll do afterwards, when you've done, because you're on the emulator, when you're done, if you could share and create a link, we will stick that in a follow-up email. So if people want to see the code that you've written and follow that example, then they can do that. So let's make sure we do that after the session. That's great. That's fantastic. I think as long as everyone at home is able to kind of follow along and has been doing some of these activities, we've done quite a lot in this session. We set out to talk about how to drive the sense hat. We set about talking about like controlling the LEDs and also responding to the sensor data. And I think certainly our live participants have been able to do that, and hopefully you guys participating remotely have also been able to do that. What I'd like to finish with is, first of all, our final Menti question, which I'm going to go and open up now. Okay. And what I want you to reflect upon is, now that you have learned how to manipulate the LEDs and you have learned how to respond to sensor data, what else could you do? What could you make with what you've learned in this session? Okay, so I'm going to leave that question open for a moment, and then we'll go and have a look at a few of the results. So that question hopefully is open now, and you can go and put your comments in there. And just to give you a couple of ideas whilst that's happening, we have, as many of you will know already, we have a whole set of resources, a vast set of resources. There's nearly 200 resources on our website, loads of great, engaging, interactive projects. And I've picked 3 of my personal favorites that use the SenseHat, but there's loads of other great ones that use the SenseHat and loads that don't use any hardware whatsoever. So the first one is SenseHat Pong, the idea being that you can you create 2 bats on the screen and a little ball bounces across your 8x8 matrix and you play Pong, essentially. So that's a really great one. Another great idea was one taken from the success of Flappy Bird. We created one called Flappy Astronaut. So you have a little white dot on the screen, which is your astronaut, and you can float that up and down to navigate through obstacles that progressively come across the screen. And then finally, one which I've seen being run, but I've never sat down and worked through, and I really, really want to have a go at this one, is Slug, which, as the description says there, it's a recreation of the classic game of Snake on the Sense Hat, using the joystick to control that little character there. I think we have a couple of responses on the Menti board, but I'm not sure if you will be able to see it. So if we just keep my screen on, and we will try and have a look at these. Oh no, we've got a few more coming in as well. How do I see those? Don't know. We're going to have a look at those in just a moment. Okay, so I'm conscious of time, so we're going to start to think about wrapping up our session a little bit, but I'm going to try and just get some responses from that question while I'm doing that as well. So what do we have? What could you make with this? We've got, with this program, you can make a weather station. We have a compass which changes color, which is great. We also have one of my favorite student SenseHat project was a mood sensor, which used an external temperature probe in SenseHat to show an image, which is great. There's loads of sensor-related projects that can display data, and also we can do animation as well as interesting combined with writing and games. So there's a few ideas there, and hopefully a few more of those will come in. It's great to hear your ideas about where you can take this kind of project. So thank you to everyone that participated. We've got a couple of things just to talk about before we wrap up. The first of which is that this first session that we're running is hopefully our first, and we want to continue this idea of running short, interactive sessions with educators. And so the next session that we're trying out is a panel session. We're going to be joined by 4 fantastic educators, Donna, Matt, Lindsay, and Rachel, are going to join us in I think 2 weeks' time on Wednesday, the 6th of December, for half an hour between 4:30 and 5 GMT. And we're going to be talking a little bit about particularly their individual journeys of how they've transitioned into teaching computing. So they've all got a variety of backgrounds, how they've moved from whatever their background was into teaching computing. And there'll be lots of advice from them, and you guys will be able to answer questions of those educators as well. If you want to take part in that, it'd be ideal if you could go and register at rpf.io/TC register, and then we can send you out all the information that you need in order to participate. And then the very, very final thing that I want to say, first of all, I would like to thank everybody who's been remotely participating, joining in with Menti, giving us loads of great ideas that way. I'd also like to say a special thanks to Heidi and to John for joining us from where they are and being our live guinea pigs for this first session. I'd like to thank Alex, who's been behind the scenes at the back, kind of doing all the camera switching and so on. We'd really love to hear what you thought about this session. And if you go to rpf.io/OW feedback, there's a Google form there that you can use to give us some feedback on how this session was useful for you. Thank you very much. See you soon. Bye.